So this is just a real quick video to finish up the lesson today from calculus and Riemann sums. So if we look at number 1, it says let f be the function given by 9 to the x, so that's an exponential function. We're going to do 4 subintervals of equal length. We're going to do a right-handed Riemann sum from 0 to 2. So this is our starting value and this is our ending value. So if my interval's from 0 to 2, and I'm going to do 4 subintervals, then my width is going to be a half. And they don't give me a graph, so I'm going to kind of turn this into a table, because I think tables are super easy. So I'm going from 0 to 2, and I'm going up by a half. Okay, so now to get the y values, I need to plug that value in for x. So 9 to the 0 would be 1. 9 to the 1/2 means the square root of 9, which is 3. 9 to the 1 is 9. 9 to the 3/2 would be the square root of 9, which is 3, and 3 cubed, which is 27, and then 9 squared is 81. So there's my table with all my values. Now I'm going to focus on the fact that I need to be right-handed. So when I look at the rectangle that would start at 1 and go to a half, if I want to be right-handed, then I'm going to use this value, the right-handed value. So I'm going to go ahead and set up my length times width. I'm going to put my width on the outside and then just multiply by adding all my lengths together and multiplying by 1/1/2. So the right-handed value for the first rectangle would be a 3. Then the next rectangle, the right-handed value would be a 9. And then the next one, the right-hand value would be a 27. And the next one would be an 81. And add all that up and then half it, and you get 60. So I just wanted to do this example, number 1, to show you this integral notation, so you know that your interval is from 0 to 2. And also to see how to do these when you don't have a graph in front of you. Instead of making a graph, sometimes I think it's super easy to make a table. So number 2, we're going to use a left-hand rectangular method, 4 subintervals. We're going from 0 to 8, but please notice that that f of t has absolute value functions, or an absolute value bars around it, which means that any area that dips below the x-axis that would normally be negative is going to become positive. And then just for future reference, if you do have any area that dips below the x-axis, it is in fact negative. So my interval's from 0 to 8, and I'm doing 4 subintervals, so 2 is my width. I have this lovely graph. I want to do left hand, so for this one, I want this value. I'm going to go ahead and put my width is 2. Let's see, my first one's going to be a 3. Then for my second one, again, I want left hand interval, so that's going to be a 0. And then for this one, it's going to be left-handed, so that's a -4, but remember it's absolute value, so it becomes a +4. And then for this one, the left-handed is going to be a -1, but again, that's going to make it positive because of the absolute value. So 3 plus 4 is 7, and 1 is 8, and 2 times 8 is 16. Okay, and again, I know I'm kind of going at a quick pace, so feel free to pause it while you write or soak it in or rewatch it. Do what you need to do. Okay, number 3. So we're estimating from 0 to 4. You know that this guy is, oops, missed my mark, is a upside down parabola or half a circle. It's a semicircle. It has a radius of 5. I want to use the left-handed rectangle rule, and I only want 2 subintervals. So from 0 to 4, So my width is 2. And I only want 2 subintervals, and I'm going from 0 to 4. So I'm going from here to here with 2 subintervals. So I'll have another one at 2. So I'm looking at this rectangle, well, the rectangle that would do this, and I'm left-handed, so I'm going to use the left-hand mark. So if I plug in a 0 into my function, square root of 25, which is 5. And then for this one, left-handed, so I'm going to use this value, so that's 2. So I need to plug a 2 in there. That'd be 4, 21, so the square root of 21. And then I'm going to plug in a 4. No, I'm not going to plug in a 4 because that's the end. I only want 2 subintervals. So that would be 10 plus 2 root 21. And if this was multiple choice, they would leave it like that. I very seriously doubt they'd give you this problem on a calculator active. So they want the clean, pure answer like that. Number 4. Says the table below gives the velocity in miles per hour of a truck at selected time t in hours. Use a trapezoidal sum. Okay. 3 subintervals. What's the approximate distance, which is going to be the accumulation of the velocity in miles from time t equals 0 to t equals 3. So I'm going from 0 to 3, and I want 3 subintervals, so we're 1 apart. But here's the problem. It's very easy to just glance over this problem and say, okay, well, I need my intervals to be 1, and then go look at your t values and see that they don't all increase by 1. So we kind of skimmed over this really quickly, and it says 3 subintervals indicated by the table. So the table has already separated into my 3 intervals. So all my widths are not the same. This width is a half. This width is 1.5, and this width is 1. Make sure you're real clear on where those numbers are coming from. So these rectangles are not equal width. I do want to be a trapezoid, so I'm going to 1/2 out front, but I can't put my width out front because they're all different. So the width for the first one is 1/2, and then the trapezoid, remember, it's base 1 plus base 2. And I can't double up my 60 again because my widths are not the same. So I have to do these individually. My next width is 1.5. And that's going to go, base 1 is a 60 and base 2 is a 40. And my last width is a 1. And first base is going to be 40. Second base is going to be 30. So let's see, this is 1/2, and then 1/2 times 80, plus 1.5 times 100, plus 1 times 70. And I would say this is, you know, probably a fair shot for a non-calculator question. Half of 80 is 40. 1.5 of 100 is 150. And then, let's see, 140 and 50 is 190. 190 and 70 is 260. And then half of that would be 130. 130. And this is distance, so 130 miles. Okay, number 5, I want a trapezoid approximation. We're going from 0 to 3 of e to the x using 4 subintervals, and this one's going to be calculator active, which is lovely. I'm going from 0 to 3, and I'm doing 4 intervals. That's when this little process right here makes your width super, super easy. So each width is 3/4. So for trapezoidal, I got my 1/2 And I got my 3/4 as my height, which remember is your width. And I can put that out front because they're all the same. And then, you can type this in to your calculator and adjust your table so that you start at 0 and go up by 0.75, and you can see all your decimals. And so you can put all those decimals in there. For a final answer, I got 19.97. So I want you to pause this and go to your calculator, and in your y equals, put an e to the x, and go to your table set and start at 0. And then your delta x needs to be a 0.75 because that's your width of a 3/4. And then remember, when you do this in here, it's base 1 plus base 2 plus base 1 plus base 2 plus base 1 plus base 2. So your base 1 is going to be e to the 0, whatever that is. And then plus this one's going to be e to the 3/4. And then this one's going to be e to the 3/4. And this one's going to be e to the 1.5, 1.5. So you just have to keep going up, but it's all going to be in your table. The point is, don't forget the trapezoid part, the 1/2 height, base 1 plus base 2. So we have this out front, but you have to do this for each of the 4 trapezoids. So like I said, push pause, type it in, get all your decimals, and make sure that you're getting a 19.97. And then hit play when you're good. Number 6, the table shows the speed of an object in feet per second at various times during 12-second interval. Estimate the distance the object travels using the midpoint method with 3 subintervals. And again, it gives me a table, so I have to use this table regardless of how much it goes up by. And I can see, like right here, it's going up by 3, and that's going up by 3, and that's going up by 1, and 1, and 2, and 2. So this is not evenly divided, but I have to use the table. And if I want 3 subintervals, then I'm going to go here.
Attention, will Jared Cox please come to the office? Jared Cox.
Okay, so this gives me my 3 intervals. And if I use the midpoint method, then I just want to make sure that I'm in between 0 and 6. So, all right, let's see. So we're going from, let's see, my width. Okay, sorry. The width of my first one is 6. And if I'm going to use the midpoint, then I'm going to use the 14. And the width of my next interval is 2. And midpoint would be an 8. And the next one is a 4. And the midpoint's a 3. Let's see, that's a 12, that's a 16. And that's an 84. 16 and 12 is 28. 84. And 28 is 112. So again, I couldn't use one width throughout the whole thing because it's a table and all the widths aren't the same. I had to divide it into 3 rectangles, and it's midpoint, so I had to use the value of the middle of each rectangle. Number 7, suppose the graph of f is both increasing and concave up, okay? Increasing and concave up, okay? So if I'm increasing and concave up, then I have to be doing that, okay? On A to X to B, using the same number of subdivisions and width, a left, a right, a midpoint, and a trapezoid, list them in order from smallest to greatest. Okay. So let's say here are my rectangles. If I'm left-handed, I'm going to be very small, very under. If I'm going to be right-handed, I'm going to be super, super, super over. So if I had to guess, my left would be here and my right would be there if I'm placing them in order. So now I just need to compare midpoint and trapezoid. Okay, so let me erase so we have a clean graph. There we go. Midpoint. Midpoint looks really good. I mean, it's got some overs and unders, but it almost looks like they would cancel each other out. So midpoint, I'm going to say, is really close to what it's supposed to be. So now let's do trapezoid. Now here's where the concavity is really going to come into play also. If I connect these two, then my trapezoid is going to be slightly over. And this one, slightly over, just because of the concavity. And this one is going to be slightly over. So the trapezoid is going to be over, but just a little. So the trapezoid is going to be over, but just a little, and the midpoint is going to be good, but the left hand is still going to be really, really small. So if I had to put it in order, that's the order in which I would put it in. So again, I know this was fast. Feel free to watch it as many times as you need. Make sure you took really good notes. And the homework also touches on these so you'll know if you have it or not. And if you have any questions, come see me.